Okay, we're going to go through this, the solution of this question right here. So we have an air bubble inside of oil. We don't know much about this. This is all we know. We want to, he wants you to put a ray diagram, locate the focus of this lens, and state whether it's converging or diverging lens. So the trick in this question is to just remember our rules. Let's see, what are those rules? And know that we have two materials. So we know that the oil has a higher refractive index of the air. So when the light rays hits this interface, it will be sent in a different direction. We don't know if it's going to go this way or that way, and then when it hits this next interface, it's also going to be bent this way or that way. And I think in this case, it's really probably a great idea to use Pete's analogy of a car with wheels and traveling on different surfaces. So let's go to an image where we can do something like that. Okay, so Pete's diagram, he had oil. And inside this oil is a bubble of air. And we know that the refractive index for air, N is 1, and that for oil is greater than 1. It's like 1.2. And so we have these rays coming in, these light rays. And what happens when they actually hit the air? Well, back to the analogy of a car with wheels. Let's see, I'll make that car red. That'll make the wheels red. So we've got these 4 wheels coming in, and because it's a circle, we know that the first wheel to hit will be this front wheel, this front right wheel. And here's a perpendicular here, right here, perpendicular to the surface. This one, we'll do this one first. So since this is a lower refractive index, we know it's technically slipperier. So it's going to this front wheel is going to make it go faster, so it's going to turn in that direction. So it's going to turn that way, so that the light ray will go like this. And the same is true down here. So the first wheel to hit when you get let's see, on this one will be the left front wheel, and the left front wheel, since it's slipperier, will cause a turn in this direction. So the light ray will go down this way. So, and then we look at it again. We analyze this situation. Now these should be symmetric. It's just I'm drawing this in a terrible way. The front wheels like this. This left front one will be the first one to hit. And this is less slippery. So technically it'll slow it down, causing it to turn this way. So we draw a line going like this to represent how the light exits. Same thing down here. We have a wheel. The first one to hit is the right front one. This is the top view, by the way, and this is slower, so it causes to turn the car, the light ray, to turn that way. So it will bend down this way. Now these, I've done a poor job of this, but these should be, again, this is a circle. If it's a circle or a sphere, they should be symmetric. The rays should be going the same direction. Now, you notice that the rays are diverging. So already we know this is divergent. This lens is divergent. Where is the focal point? Well, F, we know that what can locate F is that well, if we have parallel rays, we know that they pass through the focal point. So these rays are parallel. So where is the focal point in this situation? Well, we need to make these rays go back like this. And if we extend these backwards, we see somewhere there is a focal point right there. So here is our focal point inside this bubble. And then what was the other question? Is it convergent, divergent, focal point? Just a second. What was it? Oh, complete the ray diagram. Okay, I think we've done it.